A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Your AI assistant remembers your coffee order from that one transcript 3 months ago, but it completely blanks on your son's name or that critical project deadline you mentioned yesterday. Why is personal AI memory still such a fragmented, siloed mess in 2026?
It is the great paradox of the current agentic era, Corn. We have models that can reason through complex physics, yet they have the situational awareness of a goldfish because their long-term memory is trapped inside specific app databases. If you tell a medical AI about your allergy, your travel AI doesn't know to avoid booking a hotel with feather pillows. The brain is there, but the hippocampus is owned by a dozen different corporations.
Right, and today's prompt from Daniel is really hitting the nail on the head here. He is asking about the best way to build a portable, federated, and persistent personal memory layer. He wants something that can handle at least 2 namespaces, one for work and one for personal, that can live in the cloud for convenience but must be mirrored locally so he actually owns the data.
I love this prompt because it moves past the how do I talk to a PDF stage and into the how do I build a digital Horcrux stage. We are talking about the architectural challenge of building a memory stack that is framework agnostic. Whether you are using Claude, a local Llama instance, or some experimental agent on GitHub, they should all be able to plug into the same memory USB port, so to speak.
It is a timely deep dive too. We have seen massive updates from Mem0, Letta, and Zep just in the first quarter of 2026. By the way, fun fact for the listeners, today's episode is actually powered by Google Gemini 3 Flash. It is the brain behind the script today, which is fitting since we are talking about how these models handle or fail to handle persistent context.
It is very meta. And before we dive into the weeds of vector stores versus graph databases, let's define what Daniel is actually hunting for. He wants a memory layer that is portable, meaning he can move it, federated, meaning it can exist in multiple places at once, and persistent, meaning it does not vanish when the session ends.
And the namespaces part is key. I do not want my AI agent suggesting a playful bedtime story format for my quarterly earnings report just because I spent the last hour talking to it about Ezra. There has to be a hard wall between the dad side of the brain and the tech communications side of the brain. But how do you actually enforce that wall? Is it just a folder structure, or is it deeper in the math?
It's deeper. In a vector database, everything is just a point in a high-dimensional space. If you don't use strict metadata filtering, the semantic similarity between a story about a kid going to sleep and a report on market dormancy might be high enough that the AI gets confused. You need a system where the retrieval query explicitly says, only look at points tagged with work.
Well, not exactly, but you have hit on the core architectural requirement. The industry has been moving toward this idea of data sovereignty, where the user owns the vector embeddings. If a SaaS platform like Mem goes under or changes their terms of service, you should be able to point your local agent at a local file and say, everything I told that other bot is right here. Keep going.
That's the data exit strategy Daniel is looking for. It's the difference between renting your memories and owning them.
So, where do we start? If I'm Daniel and I want to build this today, do I go cloud first with a local mirror? Or do I go full hermit mode and self-host the entire stack?
That is the fork in the road. Let's look at the cloud-first path first, because for most people, the UX friction of self-hosting a full memory server is still pretty high. Mem, the platform, not the framework, Mem0 released a local mirror feature in January 2026. This is actually a huge deal for this specific use case.
How does it work in practice? Is it just a CSV export, or is it something more alive?
It is more sophisticated than a flat file. It essentially treats the cloud as the primary coordinator but maintains a local SQLite instance with vector support, usually via the VSS extension on your machine. When you add a memory in the cloud, it syncs down. If you lose internet, your local agents can still query that local mirror. It solves the SAS province problem. Daniel mentioned because the source of truth is replicated on hardware you own.
But what about the federated part? If Daniel is working from his laptop at a cafe and then moves to his desktop at home, does the local mirror stay in sync across both devices?
That's where the cloud acts as the relay. The cloud holds the master encrypted index. Your laptop and desktop both pull from that master. But, and this is the crucial part for Daniel, if the cloud service vanishes tomorrow, you still have that SQLite file on both machines. You haven't lost the intelligence you've built up over months of interaction.
Okay, but what if I want more control? What if I do not trust the sync logic, or I want to use one of these newer frameworks like Mem0 or Letta?
Then we get into the memory stack contenders. Mem0 is probably the closest to what Daniel is looking for in terms of being framework agnostic. It is designed to be a library that sits between your data and the agent. It focuses on entity-centric memory. It is not just storing a transcript, it is extracting facts. Daniel lives in Jerusalem. Daniel likes dark roast coffee. It stores these in a structured hierarchy, user, then session, then memory.
I like that entity-centric approach. It feels more like how a human actually remembers things. We do not remember every word of a conversation. We remember the updates to our internal model of a person. But how does Mem0 handle the namespacing? If I have 10,000 memories about work and 5,000 about my family, how does it keep them from bleeding into each other during a query?
It uses metadata filtering. Every time a memory is written to the underlying vector store, whether that is Kudrant, Pinecone, or a local Chroma instance, it attaches a namespace tag. When the agent asks a question, the framework injects a filter into the search. It says, "Give me the most relevant memories for this question, but only where namespace equals work." It is simple, but it is incredibly effective for preventing that cross-contamination you were worried about.
But what happens if a memory belongs to both? Like, I need to buy a new laptop for work, but I'll use it for Ezra's school projects too. Does the system struggle with dual citizenship memories?
That's a classic edge case. Most of these frameworks allow for multi-tagging. You can tag a memory as both work and personal. When you query either namespace, that memory is available. It's like a shared folder in a file system, but instead of moving the file, you just give it two keys.
Let's talk about Letta for a second. They used to be MemGPT, right? They have a bit of a different philosophy. They talk about memory like it is a computer's operating system, RAM and disk.
They do. Letta is much more opinionated. In Letta's world, the agent is stateful. It has core memory, which is like the immediate context window things the agent always knows about you. Then it has archival memory, which is the massive vector store of everything else. The wild part about Letta is that the agent itself manages the memory. It can choose to write something to archival memory or edit its core memory based on the conversation.
That sounds cool, but also a little scary. If the agent is the one deciding what is important enough to remember, what happens if it hallucinates a deletion? I would hate to wake up and find out my AI decided my anniversary wasn't worth the disk space.
That is a legitimate concern. In fact, developers in the community have noted that while Letta feels more human because it is self-editing, it can suffer from those hallucinated deletions. It is a forever agent framework, but it requires a lot of trust in the model's ability to self-reflect accurately. For a work namespace where data integrity is paramount, that might be a deal breaker. You might prefer the more structured, extractive approach of Mem0.
How does Letta handle the portability aspect, though? If the memory is part of the agent's state, can I move that state to a different model? Like, can I take a Letta agent trained on GPT-4 and move it to a local Llama 3?
In theory, yes, because Letta abstracts the memory storage into a separate database. But since the core memory is often formatted specifically for the way a certain model follows instructions, there's some translation friction. You might find the agent becomes a bit clumsy after the transplant until it readjusts to the new model's reasoning style.
What about Zep? You mentioned they have a temporal knowledge graph. That sounds like something out of a sci-fi movie.
ZEP is fascinating because they argue that vector search alone is a dumb way to do memory. If I say, I used to work at Google, but now I work at Anthropic, a traditional vector search might pull up both facts because they both contain the word work. ZEP's graph-based approach understands the relationship and the time element. It understands that Anthropic is the current state, and Google is the historical state.
So it handles the evolution of facts. That seems critical for a personal memory layer. Humans change, projects change. If my memory layer is just a big bucket of vectors, it is going to get very confused very quickly as my life moves forward. Can you give me a concrete example of how that looks in a work context?
Sure. Imagine you're a project manager. In January, the deadline for Project X is June 1st. In March, it shifts to August 1st. In a vector store, a search for Project X deadline returns two conflicting documents. The AI might say, the deadline is either June or August. In ZEP's temporal graph, the June node is marked as deprecated or historical, and the August node is active. The AI doesn't hedge, it knows the current truth.
That's a game changer for professional use. It prevents the AI from being that annoying colleague who brings up old info from a meeting 3 months ago that everyone already agreed to ignore.
ZEP's benchmarks for March 2026 show they can extract and store relationship data with about 87% accuracy. That is a huge step up from just semantic similarity. If Daniel wants a memory layer that can actually reason about his life, like, who did I talk to about the automation project before I moved to Jerusalem? A graph-based system is going to run circles around a standard vector store.
Okay, so we have the frameworks. But let's talk about the stack hunt Daniel mentioned. If I want this to be truly framework agnostic, if I want to use it with Claude Desktop 1 minute and a Python script the next, how do I bridge that gap? Because right now, every framework has its own API, its own format, its own way of doing things.
This is where we have to talk about the Model Context Protocol, or MCP. This is the USB port we have been waiting for. Anthropic introduced it, but by now, in early 2026, it has become the de facto standard.
Explain MCP like I am a sloth who has been napping through the last 6 months of dev news.
Think of MCP as a universal translator. Instead of building a custom integration for every AI tool, you build an MCP memory server. Your memory server holds your Mem0 or ZEP instance. Any MCP-compatible client like Cursor or the Claude app or even open source agents can just plug into that server. The agent says, hey, I need some context on automation project, and your MCP server handles the vector search, the metadata filtering for the work namespace, and the retrieval, then hands back the relevant bits in a format the agent understands.
So the portability Daniel is asking for isn't just about moving the data, it's about the interface being standardized. If I have an MCP server running locally, I can point any new AI that comes out at that local address and boom, it has my work memory immediately. No reindexing, no uploading my life to a new startup's cloud. But wait, how does the federated part work with MCP? If I have multiple servers, does the agent know which one to talk to?
You can actually chain MCP servers. You could have one local server for your personal files and one cloud-connected server for your work memory. The client, the AI sees both as available tools. When you ask a question, the AI decides which tool to query based on the context of your prompt.
That is the dream, and it is actually becoming a reality. The local first strategy Daniel mentioned fits perfectly here. You could run a local quadrant instance in a Docker container, use Mem0 as the logic layer to handle the entity extraction, and wrap the whole thing in an MCP server. For the work namespace, you could have a background job that syncs that local quadrant instance to a cloud-hosted version like MongoDB, Atlas, or Pinecone. That gives you the federated part. Your work laptop and your home desktop are both syncing to the cloud work hub, but your personal namespace stays on your local machine and never touches the internet. I love that. It is the privacy sandbox approach. My work stuff is shared and accessible everywhere, but my personal thoughts about Ezra or my private notes stay on my local silicon. But let's get into the why of the vector store limitations. You said developers are building their own layers on top of things like Pinecone. What is missing? Why can't I just use a vector database and call it memory?
because a vector database is just a storage locker. It doesn't have a brain. It doesn't know how to summarize a long conversation into a single memory. It doesn't know how to forget things that are no longer true. If you just dump every chat log into Pinecone, your retrieval quality is going to degrade over time. You will get noise from 3 years ago drowning out the signal from this morning.
So, the memory layer is actually a set of functions. It is a summarizer, an extractor, a ranker, and a purger.
Beautifully put. And that is what frameworks like Mem0 and Zep provide. They handle the maintenance of the memory. For example, Zep has a feature that automatically generates summaries of past conversations as they age, so you are searching against high-level concepts rather than thousands of individual lines of dialogue. That reduces latency and improves the hit rate for relevant context.
Let's talk about the hardware for a second. If Daniel is running this locally, what does that look like? Is he going to need a rack of GPUs in his living room just to remember his grocery list?
Not at all. That is the beauty of this. Storing and searching vectors is incredibly lightweight compared to running the actual LLM. You can run a Cudrant or Milvus instance on a modern laptop or even a high-end Raspberry Pi. The heavy lifting happens when you generate the embeddings, the numerical representations of the text. But even then, you can use small, local embedding models that run in milliseconds on a standard CPU.
So the local mirror isn't a performance hit, it's just a bit of disk space and a tiny bit of background CPU. Does it affect battery life on a laptop?
Negligibly. If you're indexing 10,000 documents at once, you'll hear the fans kick on. But for the day-to-day trickle of memory updates, saving a conversation here, a note there, it's roughly the same energy impact as a background email sync.
I mean, exactly in the sense that you are correct. The real challenge isn't the hardware, it's the federation logic. How do you handle conflicts? If I update a memory on my phone and my laptop at the same time, which one wins? That is where the SAS bridge becomes useful. Using something like MEMS January 2026 local mirror sync handles that messy distributed systems logic for you, while still giving you that local copy. What about the open standards part? Daniel mentioned they are conspicuously absent. Is MCP the whole answer, or do we need something more, like a universal memory format?
We definitely need a format standard. Right now, if I move from Mem0 to Zep, I have to re-index everything because they store metadata differently. They might use different embedding models. A universal memory format would be like the .vcf file for contacts. You should be able to export your AI memory as a standard file and import it anywhere. We are seeing some movement there with the Open Memory Initiative, but it is still early days. Most companies are still incentivized to keep you in their memory silo.
Of course they are. If they own your memory, they own your loyalty. It is the ultimate lock-in. If I switch from one AI assistant to another, but the new one doesn't know who I am or how I work, I'm going to switch back. It's like trying to switch phones in the early 2000s before we had cloud contacts. You had to manually type in every number. Nobody wanted to do it.
That's a perfect analogy. We are currently in the SIM card era of AI memory. The data is there, but it's a pain to move. Daniel's push for portability is essentially a demand for the smartphone era, where the data lives independently of the device or the service provider.
Which is why Daniel's insistence on local first is so smart. If you own the vector store, you are the one in control. You can point any model at your data. Let's do a case study. Imagine a developer, let's call him Dano, who is building a personal productivity agent. He wants it to help him with his work emails, but also remind him of family events. He uses Letta for the personal side because he wants that human-like self-editing feel for his personal growth notes. But for work, he uses Mem0 because he needs that rigid, fact-based extraction for project specs. Can he run both?
He can, but the federation becomes the headache. He would essentially be running two separate memory brains. The dream is to have one underlying storage layer, say, a single Cudrant instance, and then use different lenses or frameworks to interact with it. But we aren't quite there yet in terms of interoperability. Most of these frameworks want to own the database.
So if you are Daniel, the recommendation is to pick one core engine and stick with it for both namespaces.
Yes, and based on his requirements for portability and framework agnosticism, Mem0 is the current winner. It is designed to be a library, not a platform. You can use it inside a LangChain script, a Crew AI agent, or a custom Python loop. It doesn't care. It just provides the memory functions Daniel needs.
And for the storage, he should go with something like Codrant that can be self-hosted but also has a managed cloud version.
That is the path of least resistance. Self-host Codrant in Docker for the personal namespace. It stays local. For the work namespace, use Codrant Cloud. Mem0 can talk to both. Then use a simple script to mirror the Codrant Cloud work collection down to your local Docker instance every hour. Now you have local ownership of both, but global access to the work stuff.
And then wrap it all in an MCP server so we can use it with Claude or Cursor.
Bingo. That is the gold standard stack for early 2026. It gives you the sovereignty, the namespaces, and the flexibility.
Wait, I have to ask, how does he handle the work laptop? Most companies are pretty sensitive about running Docker containers or syncing data to personal local mirrors. Does this stack survive a corporate firewall?
That's the beauty of the managed cloud branch for the work namespace. On his work machine, he doesn't need the local mirror if the IT policy forbids it. He just connects his agent to the Codrant Cloud instance. The local mirror happens on his personal hardware, pulling from that same cloud instance. He gets the backup without violating the no local data policy on his work-issued hardware.
Smart. Very smart. I want to go deeper on the knowledge graph aspect that Zep uses. You said vector search is dumb. Why? Give me a concrete example where vector search fails, but a graph succeeds in a personal memory context.
Okay, imagine you tell your AI, my son Ezra is starting nursery school in July 2025. 6 months later you say, Ezra really loves his teacher Sarah. A vector search for Ezra might pull up both of those. But if you ask, when did Ezra start nursery school? The vector search might just give you a bunch of snippets about Ezra. A knowledge graph has a node for Ezra, a node for the nursery school, and a relationship called started at with a date, property of July 2025.
So it is the difference between a pile of notes and a structured database.
And Zep's temporal part is key. It can track how those nodes and relationships change over time. If Ezra moves to a different school, the graph doesn't just add a new vector, it updates the current school relationship. This prevents the agent from getting confused and telling you Ezra is at 2 schools at once.
That seems like a lot of work for the AI to maintain. Does that add a ton of latency? I mean, if it has to rebuild the graph every time I say hello, that's going to be a slow conversation.
It doesn't rebuild the whole graph. It just does an upsert, an update, or insert on the specific nodes mentioned. Zep uses a background worker pattern. You talk to the AI, and the AI responds instantly using the current state. Then, a few seconds later, the graph worker wakes up, analyzes the new transcript, and updates the database in the background. It's asynchronous.
This feels like the second-order effect of the memory architecture. If you choose a dumb vector store, your agent is going to feel vibey. It might get things right, but it will be fuzzy on the details. If you go with a graph-based memory, your agent is going to feel sharp and precise.
That is a great way to put it. And for work memory especially, sharp is what you want. You don't want vibey when you are asking about a technical spec or a client-specific feedback from 3 weeks ago.
What about the privacy side of this? We keep talking about local first, but if I'm using an LLM like Claude or Gemini to process the memory, to summarize it or extract facts, isn't my data still hitting their servers?
It is. That is the privacy leak in the current stack. Even if your database is local, the brain doing the maintenance is in the cloud. Unless
Unless you use a local model for the memory maintenance.
Right. In 2026, we have models like Llama 3 or Mistral that are small enough to run locally and are surprisingly good at summarization and entity extraction. If Daniel is serious about the personal, namespace never touching a SAS, he needs to point his mem0 instance at a local OLLAMA or VLM instance for those specific memory maintenance tasks.
That sounds like the ultimate sovereign stack. Local Quadrant, local mem0, local llama for processing, and an MCP server to bridge it to whatever agent he wants to use. But let's be real. How much technical debt is he taking on here? Is he going to spend more time maintaining his memory than actually using it?
That's the risk. We call it the tinkerer's tax. You spend all weekend configuring your local vector store and zero time actually working. That's why the cloud with local mirror option is usually better for most people. You get 90% of the sovereignty with 10% of the maintenance.
Let's talk about the work side again. Daniel mentioned he's in tech communications and automation. In a professional setting, memory isn't just about what happened. It's about who knows what. Can these memory layers handle multi-user memory? If Daniel and his colleague Hannah are both working on a project, can they have a shared namespace?
This is where the federation part gets really interesting. Frameworks like Zep and Mem0 are starting to support group or organization level namespaces. You could have a Project Alpha namespace that everyone on the team contributes to. The agent then has 3 layers of context: general world knowledge from its training, team knowledge from the shared namespace, and Daniel's knowledge from his personal work notes.
That sounds like a compliance nightmare for HR, but a dream for productivity.
It is both, but the technology is there. The namespacing via metadata we talked about earlier handles this. You just add a tgroup tag to the memories. The real challenge is the sync logic across a team, but using a managed vector store as a service makes that relatively trivial.
What are some of the practical takeaways for our listeners who aren't quite ready to build a full MCP server this weekend? If they just want to start moving toward a more persistent AI memory, what's the first step?
The first step is to stop treating every chat like a one-off. Start using a tool that has some form of persistence. If you are a developer, start playing with Mem0. It is the easiest on-ramp because you can plug it into your existing Python scripts with about 5 lines of code.
And for the non-developers?
Look for apps that support MCP. If you use Claude Desktop, you can already start adding MCP servers that give it access to your local files or local databases. There are community-built MCP servers for things like Obsidian Notes or even your local Apple Notes. That is a form of memory that doesn't require a complex vector stack.
That is a great point. Memory doesn't have to be a high-tech vector graph. Sometimes it's just a searchable folder of markdown files that your AI has a window into. If you've been taking notes in Obsidian for 5 years, you already have a personal memory layer. You just need an MCP bridge to let your AI read it.
Precisely. In fact, for Daniel, the personal namespace might already exist in his notes. He might not need to build a new vector store from scratch. He might just need to index what he already has.
I mean, you are right. We often overcomplicate the memory part because vectors are the shiny new toy. But for a lot of work context, a well-organized folder of project docs is a much more reliable memory than a fuzzy vector search. The stack hunt Daniel is on is about finding that perfect balance between the structured and the fuzzy.
It's about the context window versus the knowledge base. The context window is what the AI is thinking about now. The knowledge base is everything it could think about. A good memory layer is the librarian that fetches the right book at the right time.
I think the biggest takeaway for me is this local mirror concept. The idea that I can have the convenience of the cloud, but the insurance policy of a local copy. That feels like the social contract we should be demanding from all these AI startups. I'll give you my data to make your service better, but I get a copy of the brain you build with it to keep under my bed.
It's the data exit strategy. Every AI tool you use should have one. If it doesn't, you are just a tenant on someone else's land.
Well, I'm a sloth, so I'm very comfortable staying in one place, but I still want to own the tree.
And you should. We've covered a lot of ground here, from the temporal knowledge graphs of Zep to the operating system feel of Letta and the modular library approach of Mem0. It feels like we are at a turning point where memory is becoming its own distinct layer of the tech stack, separate from the reasoning layer of the LLM.
It's the decoupling of the brain. We have the processor in the cloud and the hard drive in our pocket.
That is exactly how it is playing out. And the people who figure out how to build that hard drive in a way that is portable and standard are going to own the next decade of computing.
Any final thoughts on Daniel's work versus personal split? Any pitfalls he should watch out for as he builds this federated layer?
The biggest pitfall is context mirroring. Even with namespaces, if your retrieval logic is too aggressive, the agent might still pull in work context when you are asking a personal question if the semantic similarity is too high. You really have to be disciplined about that metadata filtering. Don't just recommend. The namespace to the agent, hardcode, the filter in your API call.
Trust, but verify, with a metadata tag.
Precisely. Well, not precisely, but you've got it. And keep an eye on the latency. As your memory grows to millions of vectors, that local mirror is going to need some indexing optimization. Don't just dump it all into a flat file and hope for the best.
This has been a fascinating deep dive. I feel like I need to go home and check the namespaces on my own brain now. Make sure I haven't left any work memories in the personal bucket.
Just don't delete the Herman node, corn. I'd hate to have to reintroduce myself to you every morning.
Don't worry, your core memory, Herman, for better or worse.
I'll take it. Big thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes.
And a huge thanks to Modell for providing the GPU credits that power the generation of this show. We couldn't do these deep dives without that kind of horsepower.
This has been My Weird Prompts. If you are enjoying these technical explorations, we are on Spotify if you haven't followed us there yet. It's the best way to make sure you never miss an episode.
Find us at myweirdprompts.com for the RSS feed and all the other ways to subscribe. We'll be back next time with whatever weirdness Daniel, or the world, throws our way.
See you then.
Stay weird and persistent.
And portable.
Don't get me started on portable sloths. That is a whole other podcast.
I'm pretty sure that just means someone is carrying you.
I mean, you are correct, Herman. You are correct.
Goodbye, corn.
Goodbye, Herman Poppleberry. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to